Okay, here we go. Everybody happy today? Yeah. You look thrilled. You look thrilled. All right. All right, so we have a test on Monday. So I have a review for you that I'm going to hand out today, and we're going to work on it together as a group. But I'm not going to give that to you until after we finish the material. So we have a little bit more to do. Then once we do that, I'm going to go down to my office and I'll give you your break. Go down to my office and I'll grab the review. I'll bring it back up and probably let you work on it by yourselves for about half an hour. Then after that, we'll talk about things that you have questions on. All right? So that's our plan today. Last class we were looking at, well, let me just scroll up here. Towards the end of class, we were given a function like this, and we were asked to evaluate the function. So plug things into the function, and I think I changed it, right? I made it 9x squared. And we were asked to plug numbers in, and then, this meant something else. We talked about that, and we worked through it, and I think everyone got it. Now, on the second part of this, we're going to do it backwards. We are going to be looking at the graph of a function, and from that trying to determine some information. So remember with a line, when we had like a line, the whole idea behind a line was that if we have an equation like y equals, let's say, 2x plus 1, if we graph this, it would look like this, okay? That would be this line. And remember that the line meant all the points that were solutions to this equation, right? And so we could have looked at this at plugging in values of x. Like if I plug in, let's say, 0 for x, I'm going to get 1 for y. If I plug in 1 for x, 1 times 2 plus 1, I'm going to get 3. We keep doing this, right? Yes? Okay. So this right here, this value that we're plugging in is the x. And the value that comes out is the function's value at x. So input, output. So when we're looking at this graph right here, the first question that's being asked is for us to figure out what the function's value is at 3. So what this is really saying is, look, we have an input of 3. The question is, what is the output? All right? Does that kind of make sense? So if I go to this graph, how am I going to determine what the value of the function is at 3? Can someone explain how I'm going to do this?
Wouldn't you just go to the 3 on the x?
Okay, so since the input is x, I'm going to go to 3 on the x. And then, so let me go to the 3 on the x. That's 1, 2, 3. And now what?
You would go up.
We go up and we look, where do we have a dot? Right? So we have a dot actually right there. Now, it's part of a line, but remember, every point on the line, right, makes up the whole line. Are there a bunch of dots? So what we're being asked here is when 3 is plugged in, this is what comes out. Now, how high is this? What's the value of that? 4, right? So this would be 4. That okay? Yeah. Okay, let's try the next one. F of negative 3. So now you're saying if you let x be negative 3, what is the output going to be? So what does it look like to you? F of negative 3. So go to negative 3. 1, 2, 3. There's negative 3, right? And look for the dot. So here's the dot right there. And what is the value of that? 1, right? It's 1 unit up. So this would be 1. I'm not sure if you're getting this. It's just too easy. How do you feel? Is this all right? Let me try this next one. Let's go with f of 0. And let's start pulling some sticks.
Can you repeat that? I'm sorry, I didn't get that.
Which one?
How, like when it's minus 3,
Okay.
how did it get to be like 1?
Okay, well, when you go to minus 3, right? what you're basically saying is, okay, you're looking right there, and what you're doing is you're looking up and down here, and you're saying, where do I hit the picture? Where do I hit the graph? And do you agree that I hit the graph right here? Right? That's where that line comes down, and so at -3 I go up, that's where I have a point. Right? Now, how high is that point off the ground? How high is it? It's 1 unit up, right? Let's do the next one, f of 0, and I'm going to pull my sticks here. Let me silence my phone. Okay, so these are the ones. Got more people here today. David, where's David? All right, David. So f of 0, what do you see? 4, right? So if x is 0, that means you're not moving left or right, right? So you're starting here at 0, and you're looking up and down trying to figure out where the graph is. So when you look up, you see that the graph is right there, and that is 4 units high, right? So your answer is 4. F of -4. Luke is up.
0.
F of -4 is 0. What do y'all think? So when you go to -4, 1, 2, 3, -4, right? And then you start looking up and down, but you're actually on it already, aren't you? I mean, that's where it hits. And how high is that point? 0, right? It's not up or down, so this is 0. All right, let me give you a couple more. How about f of -7? And let's go with, who's that? Let's see who this is. Alyssa. Alyssa? Would it be? Or are you asking me, or you? Remember what I said about confidence. What do you think? So what do you think it is? 4? So you're going to -7 over here? Did you go this way? 1, 2, 3, 4, 5, 6, 7 right there. And then you went and looked up and down, it was down, right?
Oh, yeah, I went up. That's
You went up.
fine.
Okay, so it's 1, 2, -3, right? So that looks like it's -3. Make sense? All right. How about f of 10? And let's go with Tanisha. -6. So is f of 10 or -10? F of 10, right? So it'd be 4. I think you went that way, didn't you?
Yeah.
Okay, so remember, because it's 10, right, everyone? We're going to be going to the right 10 to here, and then we're looking up and down. We see it hits right up here. And that is 4 units up, so 4. Do I need to keep doing this, or should I move on? Move on? Okay. Let me ask a different question then. If f of x equals 2, find x. Okay, so this is where things can get a little tricky for people. So Brianna Garza. These are our Briannas, right? They're not here. Jameson. So, Jameson, when you see this, do you see the difference between this?
Yeah.
Okay, so this time they're not giving us the x, right? They're actually giving us the output, right?
Yeah.
The output. So they're asking us, what x would give you an output of 2? So what do you think? -3? It's close. I think it may be a little hard for you to see this, but so what we're doing is we're saying, where's the output, right? Where's our output our height of our output 2. So we look along and we're looking saying, okay, look left and right. Where do we have 2? It looks like it happens about right there, right? And then if you go straight down from there, we can figure out the x value that it comes from. So this is backwards from the previous, right? Instead of giving you the x and you figuring out the height, this, we're giving you the height and you're going backwards to find the x. So what is the x? What did we say? -2? Makes sense? Let's do another one. How about if f of x equals 0, find x. Victor. Where's Victor? Okay, Victor. -4. So we actually kind of did this one already, but we did it the other way, didn't we? Yeah. So let me erase everything so it doesn't get confusing. So you're basically looking at this saying, where is the height of the function 0? And you say, well, 0 is here, so that only happens right there. And then the x value corresponding to that is -4. Yay or nay? Yes?
I got a question.
I think, go ahead.
So is it the same thing as just figuring out the equation? So you say f of number, and you have the equation, and you're just figuring out the output of that equation. It's the same thing that we're doing now, right?
Except we don't have the equation. That's the big difference. Here we just have the picture, right? So if someone gives you an equation, they can give you x, and then we can tell you what the output is. Or we can give you the output, and you can go find x. That's what we did in the previous class, at the end of class. But I gave you an equation. So we did everything algebraically with no pictures. Now there's a picture, no equation, and we're trying to still use the picture to give us these answers. All right.
Yeah, I think
Go ahead.
Well, but I think what he's asking, like, we could still find the output, right, with that equation. So if they gave us f of x, whatever that is, and then they gave us the equation, we solved that equation, and that's the output, right?
Yeah, if they gave us, if they told us f of x equals 0 and they gave us the equation,
Yeah.
then we could solve for x.
Okay.
We just don't have the equation, so we have to rely on the graph. Now I have a difficult one, so someone's going to get unlucky here. Okay. If f of x equals 4, find x. Mix these up a little bit here. Nivini? You're the lucky one, or unlucky one. Do you see the problem? Do you see what the issue is with this? Like what the difficulty is?
No.
No? Okay, so do you think you have an answer?
Well, I wasn't here yesterday, so I think.
Okay, well go with it.
Is it if f of x is 4, would you just go up 4 or no?
Well, the last few problems that we've been doing, this number right here has been the height, right?
Yeah.
And then what we did is we found the height and we went down to try and figure out where that happened, what x value gave us that height. So do you see anywhere on this graph where the height of the function is 4? Yes, right? Actually, anything here, right? Any point along this line segment here would have a height of 4. Agreed? So what x value gives you 4?
All positive numbers.
All of these numbers, right? So you could say, all right, I can go here. That's 4, right? So that came from what? 0. So that would be correct. But you could also say this one right here is 4. The height's 4. And that came from 1. Or you could do this one, but that one comes from 2. The next one comes from 3, right? But it's also everything in between there. Agreed? So this is a difficult question to answer because there's not just one answer for x. There's actually an infinite number of answers. Every number between, 0 and out. So I heard someone say x greater than or equal to 0. That'll work. Any x that's bigger than or equal to 0 would work. And that's because, well, we're assuming this graph continues that direction. So if you plug in 0 to work, plug in any number bigger than 0, and it will still spit out 4.
So that's how you would.
This is it right here. Find x.
So that's the actual answer.
That's the answer, yeah. X is greater than 0, or equal to 0. So it can get a little tricky when you have a graph that has a flat line like that, because then you have multiple points, right? Okay, let's do another one. We're going to do this again. I'm going to draw a new picture, all right? And then I'm going to ask you some questions. I'm going to let you work on it for a minute, and then we'll go over them, all right? Okay, so let me, where is it? Yeah, that'll work. That should work. This is one of those topics where it's like when it doesn't make sense, it's very confusing, but as soon as you understand what's happening, it's like a light bulb goes off and you're like, got it, you know? And it's once you get it, it's kind of hard to trick people with this type of problem. All right, so we're going to have our x-axis, that's our y-axis. And then we're going to have our x-axis here. And then I'm going to give you a function. So let me draw something here for you. Squeaky. Squeaky. Okay, that marker's dead. Try that. Much better. All right, so this is going to be 1, 2, 3. 1, 2, 3. Okay, so now let me give you some problems. You ready? All right, first one, I want you to find these values. Okay, so that's what, 7 different things to find. After you do that, all right, so let's take 4 minutes to see how far you can get with this. So quiet in here, jeez. I don't mind if you ask your neighbor if they got the same thing, you know, it's okay. Just can't do it on the test on Monday. Okay. Yes.
Sorry. I don't know if you're going very fast, but I missed the part where you were on doing the function. Which number determines left or right?
X.
Okay. So on the first two problems, the number in the center determines left or right.
This is X. So it's saying if you plug this in for X and send it through the function, what comes out for your Y value, your height. This one, giving you the height, I'm telling you the height is equal to this, and I'm asking you for the X that gets you there.
That's for the height.
That's the height. Usually on exams, when I get to a problem like this on exam, the student gets it usually completely correct or completely wrong. Like I said, you either see it or you don't. So I'm here to try and help you see it if you're having trouble, all right? That way Monday you can do well. Just another minute and then I'm going to start calling names here. If you weren't here last class, we did a quiz, and it was just an attendance quiz. So it was just a quiz for being here. So I will drop at least one quiz at the end of the semester, at the end of the summer. At least one will be dropped, so don't freak out about that. But please be here.
We drop our lowest.
Not lowest exam, no. Now, sometimes I might be able to do something with that. Let's just see. I don't like to say in the very beginning, I'm going to drop an exam, because then everyone thinks they have a free pass on an exam. I'd rather you try your best on every one of them, and at the end, maybe we do something.
Okay.
Yeah. Because sometimes you just have a bad test. You know, it happens. Okay, we ready? Well, ready or not, here we come. So Laura's up first. Laura? Okay, Laura, you get the first one.
Is it negative one?
Is it? Or it is? It is -1. What do you all think? Let's do a vote. Show of hands. How many of you agree with this? How many of you are unsure? Okay, so let's see. Laura, you did -3 for x, right? So you went on the x-axis, left and right, you went 1, 2, 3, -3, and then you looked up and down to try and see where there was a point. You found this point, and then you went back over here to figure out that height. And that height is -1. So that is correct. Did that help at all, my explanation? What are you not seeing? We need the light bulb to go off.
It's negative that you went down, right? Or is it because it's the graph?
Which part, this or this? Are you understand this -3 is the x, so we go 1, 2, 3.
Yes, and
Okay.
then you went down because...
I went down because that's where my graph is, right?
Yes.
So I'm saying if I just go straight down from here, I'm going to hit the graph right there. Then I look back over here and I say, hey, how far down is that? That's -1 down, right? Okay. Anissa, you're up next.
0.
Look at that, 0. And no question, is it 0? 0. What do y'all think? Yes? Okay, so go to -2, 1, 2. Look for the dot. It's right there. You're sitting at it, right? And that has a height of 0. So we're good. Jared, yeah. Jared? All right, Jared, you're up.
For -1, I got 1.
1. Agree? Yes? Anyone disagree? Okay, -1. Up here, 1. All right. Gabriella?
0.
0. So when you plug in 0, it's giving you 0. So at 0, you don't move, right? You just stay here, and then you look up and down. Well, again, you're sitting there, right? So that's the point. 0 goes in, 0 comes out. Good? A blank stick there. Oops. Elizabeth? Yes? Okay, Elizabeth, you're up for number 5.
Well, I got 2 answers.
Okay.
I have -1,
Okay.
and then, I got, and 3.
And 3?
Positive 3 on the,
So explain to me how you got the +3.
on the,
Oh, no, I still don't see how you got that. So this is your x, right?
Yeah.
This is your x. So that means you move to the right one. Then you look up and down, which means it's there, which has a height of -1.
But that's what the number is.
So why were you looking over here?
Because it's a line.
But you have to have, this means you have to have your x coordinate, your x stay at 1. So it's kind of like you're completely ignoring the rest of the graph completely, and you're just isolating all of your attention on what's happening right there. Okay? So your -1 is correct, but there's no other answer. Okay, how about Marcus?
-1.
At 2, you're at -1, so what do y'all think?
Yeah.
Agreed? Yes? When you go x is 2, you go down here to that point, and that height right there, that's -1. Good. Christian?
1.
1? What do y'all think? Yes? Okay, so at 3, 1, 2, 3, you look up and down. It looks like you hit there. Yeah, that's about 1 unit, so we'll go with that. Good. All right, the unluckies. Let's see here. Miranda.
So, I got 2, but I'm not sure.
You got 2 as in the number 2, or you got
I got
2 answers?
2 answers.
Yeah, so this is backwards. You want to kind of explain your rationale here, your thinking?
So when you go on the y-axis to 1,
Okay, so let me go. You hear what she said?
Yeah.
Because this is saying that your y value is 1. Instead of plugging x in, this is saying your y value is 1. So let me move my y value up to 1 right here. And now you're looking left and right, and you see it hit twice.
-1 and 3.
So when you see it hits here, everyone, then you're going down and trying to figure out what x value that came from. So that came from -1. And then over here, where it hit, you come down and you look at that x coordinate and you see it's 3. So you get 2 answers, -1 and 3. That is correct.
And so are they going to be written like a certain way, or is it just...
If you write x equals -1, well, there's a lot of ways you can write it. You can do x equals -1, comma, x equals 3. That would work. How did you write it?
I just put -1 and then I wrote up
And that's fine too. X equals -1 and 3, that would work. As long as I understand that you got 2 answers. Yes?
Can you say like x is greater than or equal to
X is greater than, okay, so the question is, can we say x is greater than or equal to -1? And then that's it?
Yeah.
Well, think about this. At -1, the output is 1, right? At -1, the output is 1. But if I go bigger than that, right? If I go anywhere bigger than that, like let's say I go to here, is my output still 1? It's not, right? This is the only place the output is 1. Here is the only other place. Sorry, so there's 2 places. So you can't include everything in between because in between it's not spitting out 1. Good question. Okay, Devon? No? Not today? Paris? You get the harder one. Let's try and go through this again, Paris. This is saying the y value is 0, right? So y value is like this. I'm going to go put a y. I want you to tell me where y equals 0 is. Tell me where I should put this if
So-
y is 0.
-2,
Okay, I think you already get it then. Okay, so this is y is 0, right?
yes.
So you're seeing it hits here at -2,
It also hits at 2.5.
at 2.5, right? And
0.
0, right? So there's 3 answers. There's 3 answers. X equals -2, 0, and you said 2.5? All right, 2.5, 2, you could write 2.5, that's fine. So I'm just separating my answers with commas. Are there any questions on that one? All right, and finally, here, why don't you pick one of those? Danny. Yep. So Danny, this is, I think, the hardest one, okay? You think you have something?
It's x greater or equal to 1.
Okay, good. So that's partially correct. So you see that something weird's happening here. All right, so this means your y value is -1. Everyone, let's go to y is -1, which means we're looking here, right? I'm going to keep it raised. I'm going to kind of exaggerate this. We're looking right there, and we're looking left and right, and we're trying to see where our graph actually hits, right?
I just didn't know if it was -1 or 1.
It's the x value that we're looking at. Okay, so we're saying, would you agree that between here and here, we always are at a height of -1? So I need all the x values between here and here. Everything in between there. Agreed? But where else? Way back here at -3, right? So -3, we also have a y value that's -1. So let me show you how you write this. X equals -3. Y'all agree with that? That's where it happens. And watch this. X is bigger than or equal to 1, but less than or equal to 2. Now, what does that mean? Now, don't let it freak you out. Just think about this. Think about what this is saying. Your x value has to be bigger than or equal to 1, right? So think about all the numbers between here, right? If I pick a number between here, anything in here, do you agree that I'll be bigger than or equal to 1?
Yeah.
But at the same time, I can't be out here. I have to be smaller than or equal to 2. So everything between here and here is represented by this inequality, is what we call this. All right? So you have a single answer along with every possible number between 1 and 2. All right. I hope that's okay. You'll have to practice a little bit and see how it goes. See, y'all did good. Uh-oh. Did that example at least help a little bit? Like clarify some of your questions? All right. Where are we at? Okay, so this is the example we just did. And then I believe the homework is next. So see, on the homework, they give you a function. They ask you to evaluate it, just like we did in class last time. Then they give you a graph. So here's the graph they give you. And then they ask you for some things. All right? All right, last topic before we can start talking about the review, and that is applications of linear functions. So what we're doing here is we are taking this idea, and I'm going to put this off camera. We started with the idea of a linear equation, and we basically broke it down to, there were actually two forms, but y equals mx plus b was our slope-intercept form. And we should be able, if someone gives us an equation like this, y equals mx plus b, we should be able to graph this, and you were supposed to do that for your homework. All right, and then we get this idea of a linear function, and the only difference between a linear function and a linear equation is that we replace the y with this notation f of x equals mx plus b. All right? So that I think I will, yeah, I'll put it here. F of x equals mx plus b is a linear function. But everything is still the same as it was back with the linear equation. M is what? What does this number in front of x always give us? It's a slope. It's a rate of change, right? Yeah. It's the rate at which my graph is changing as I move. It tells me the steepness of it, right? And then this number out here, b, is going to be our y-intercept, right? That's what these things meant. But when we do applications, which are word problems, all of the word problems we're going to do right now somehow turn into a linear function. And so we're going to have special names for these, but let's continue. Let's just actually do one of these, all right? So the first one here, get out of this. Move that up a little bit. All right, so the first one here is Mr. Thompson is on a diet. He currently weighs 260 pounds. he loses 4 pounds per month. Write a linear model that represents Mr. Thompson's weight, W, after X months. All right, so we want to somehow come up with some sort of linear model that connects his weight to the number of months that have passed. All right? So somehow we need to have a linear function, something like this. All right? But it's going to connect weight and the number of months. So if you think about this, what's happening, like when he starts his diet at month 0, when no time has passed, how much is he going to weigh? 260, right? And then after the first month, he should weigh how much? 256. So you're going to subtract 4, right? Because a month has gone by. And then after 2 months, you will have subtracted 4 twice, right? After 3 months, you're going to subtract 4 3 times from his original weight. So if we look at this, linear model like this, what do you think this number is for us? 260. That's his starting weight, right? So this is what we start with. So when you think about a graph, think about it this way. When you graph a line, this is your y-intercept, that's this number, right? So if this is time here, because we're measuring, our time is in months here, right? At time is 0, it should be his starting weight. So this number should be 260. Does that make sense? Now actually, he's losing weight, not gaining weight, right? So it should go like this, shouldn't it? Yeah. So as time goes on, his weight should go down. So that means that the slope of this line should be negative, and where does that number come from this problem? The 4 pounds, right? So let's write it down. This is our first example, but watch the way I write this. His weight, instead of me writing F, I'm going to write his weight is a function of X. It is negative 4X plus 260. Again, since this is the first example, let's just write it down. Let's try and make sure we understand everything here. His weight depends on X. X is the number of months, right? It should be his original starting weight plus what we're going to do is we're going to add to that negative 4 times each month. So let's just check that this works. What would his weight at 0 months be?
260.
260. After 1 month, it's going to be, we plug in 1 here, right? So negative 4 plus 260, he's lost 4 pounds. 256, right? After 2 months, how many pounds has he lost? 8. So negative 4 times 2, right? That's what we would do. And then plus 260. So negative 8 plus 260, he's at 252. So do you see that this linear function models what's happening here? Yeah? Okay. So let's answer part B then. And let's see if... Timothy? Read part B. You don't have to read it out loud, but just take a moment to read it. Okay? So this is the master formula that we're using for this problem. What is it asking us to do with that formula?
Find how long it's going to take to reach.
Okay, so when it says how long, are they asking us to plug a value of x in, or are they asking us to figure out what x is? Figure out what x is. Because it says how many months, right? How many months? And months is the x, isn't it? The x is the months. So it says how many months will it take for him to reach 220 pounds? That means we want to know what x is that gives us an output of 220, right? So that means I'm asking myself this question. The weight at what x gives me 220? That's what part B is saying. When is this, when is that equal to 220?
After 10 months,
10 months. So how are you getting that?
it's just, okay, we made, his weight after X months is gonna be, we already given like
Yep.
20, right?
This right here is his weight after X months, and we want that equal to 220, right?
Yes.
Does that make sense to everyone? We're just taking the weight formula and we're saying, hey, when is that weight equal to 220? Right? And that means when is the weight formula equal to 220? And now, do y'all see that this is just a linear equation? You're just solving this for x now. So how would you solve that for x? What would be your first step? Esteem?
Yes.
You kind of already started this, so how would you solve that for x?
Yeah, we take 260, we subtract.
Subtract 260. Subtract 260. Goes away here.
We're gonna end up with 40.
Negative 40,
Yes.
right? Negative 220 take away 260 is negative 40. Over here, negative 4x.
We subtract each side is 4x minus 4x.
Oh, so you moved it over?
No, we subtract. No, I mean we divide.
Divide, okay, thank you. Okay, so divide by negative 4, divide by negative 4, and that will get rid of that.
And then we have x is equal to
10.
10.
Negative over negative is positive. So that's it right there. So our answer is 10 months. It's going to take him 10 months, right? 10 months to lose 40 pounds this way. Let's try another one. We're going to skip 2. This just doesn't belong in here at all. Don't like that at all. So take a moment to read that. Sorry, it was cut off there. All right. Aaron? Aaron? No Aaron? Dyson? Yes? Dyson, here, do we have to come up with the actual linear model? We don't. It's given to us, okay? So in this problem, they give us the linear model. And it says, from this, right, interpret the slope and y-intercept in terms of her salary and sales. So they just want you to try and explain in words what the y-intercept and what the slope is. So can you just first start out by helping me, what is the y-intercept for us here? Dyson's up. What is it? 20,000, right? And that's going to be dollars because this is her salary, right? Okay, and then what is the slope of this linear model, Dyson? Okay, so 0.3, and it's just the 0.3. Okay, the 0.3, the x is not the slope. All right, so let's try and interpret this. Dyson, as x here is her total sales, right? So as she sells more, is she going to make more money according to this model? How do you know that? Think about the picture of this thing. It's a line, right? Slope is what? So is it like this or is it like this? This way, right? It's sloped up. Why do we know it's sloped up? Because the slope is a positive number, right? So if we know that this line, this linear model, looks like this, has a y-intercept of $20,000, and we know that the line slopes up, right? And this right here is her sales. They tell us that right there, sales of X. Then as she sells more, right? This is like somebody who works on commission. You all know what I mean by that? They get like a certain salary for showing up every day, but then the more they sell, the more they make. So this would be increasing salary dependent upon her sales, all right? Now what about the slope? Can we interpret that any further? You're off the hook, Dyson. I want to see if anyone can interpret what the 0.3 means. Was that your hand or are you stretching? Okay, what do you think that 0.3 means?
So she gets 30% of every sale that she makes.
Okay, so here they don't really tell us what this sales is, right? Like we don't know what sales is here. Would y'all agree with that? But the 0.3 is converted to a percentage, 30%. Y'all agree with that? So she is making, that's exactly a perfect answer. She's making 30% of what she sells. Now, from this picture, we can assume that this is sales in dollars. And the reason we can say that is because her salary is in dollars, right? So she's making 30% of every dollar she sells. So if she sells $1 worth of whatever it is, she's going to make 30 cents, right? If she sells $10, right, she's going to make $3. She sells $100, she's going to make $30, right? So it all depends on what she's selling, right? If she's selling wooden sticks, she's not going to make a whole lot of money, right? Unless she's selling it in bulk. If she's selling cars, that might be something different, right? All right, does this kind of make sense? What about the 20,000? What is this for Kara? What's the 20,000 represent? Her base salary. That's it. She just shows up, boom, you know, they pay her. Okay. So remember we were talking about waitresses, right? They have a model something like that. They have a base hourly pay, and then they make a certain percent of what they sell, right? And you all agreed that it should be what, 10%? Y'all were pretty cheap in here. Was it 10%? 15, okay. All right, let's look at this next one here. And there's only one stick left. There we go. Just take a moment to read that. Gia? Where's Gia? Yeah, you're up. So I'm going to let you read it first.
The tuition at college.
Oh, yeah, you don't need to read it out loud. I'm going to ask you to answer the first part. So I want you to read it and make sense of it before I ask you. If you'd like to read it out loud, you can. Well, we got through everyone already. You ready?
Yeah, it's 135, but just 100, correct? Because you're adding the 80 and 55, because it would just be per hour, so you just do a one-time charge.
What is, okay, so if this student just enrolls at the college and doesn't take any hours, how much do they have to pay?
Just the student fee, which is
55. So part A is asking what is the one-time charge, or what we call the fixed cost? $55, all right? $55. So no matter how many hours you take, you have to pay some fee. And that's pretty much standard at any college. You have a fixed cost. All right? So what is the variable cost, Gia? What is the cost that actually depends on how many hours you take? The $80. All right? David? Wait, David? Yeah, okay, I'm gonna make sure I didn't. You're back up. Part C, David. They want the tuition written as a linear function now, where X, now they don't say it here, but we're gonna assume that X is the number of hours the student's gonna take, all right? So that student could take 1 hour, 2 hours, 3 hours. So can you help get the linear? 55, so that's our fixed cost, plus 80x. There you go, 80x. So this is our fixed cost, so that's like the y-intercept. And then this is our 80 is our slope. It's $80 per hour we take, right? So we would normally write this way, but it's not incorrect like this, but this is the way we would write it. And remember, this means it looks like this. We have 55 here, and then it goes this way. Why am I not drawing the line backwards? Like, why am I always starting here and going this way? Why am I not doing this? That would be like, this is the number of hours you're taking, right? This is x. So it doesn't make sense to talk about taking negative number of hours. So this only makes sense from 0 on. And I made the line go pretty steep, and I did that because the slope is 80, right? So remember, 0 slope, 1, 2, 3, 4, 5. I talked about this in class. And then vertical is undefined. So, all right. I did mix these up. Gia, you came back up. I mixed them. So Gia, you have part D. So how much will it cost to take 9 hours? What are they asking you to do with this function?
You plug the x into 9.
Yes, so you're replacing x with 9 because x is the number of hours. So for part D, we want t of 9. So that's 80 times 9 plus 55. Make sure you do order of operations first. It goes multiplication, right? So what's 80 times 9? Should be 720, right? And then plus 55, which is $775. I should put a dollar symbol up there. So for this student, it should cost $775 to take 9 hours. Christian.
Yes, sir.
When I was in college, I lived alone in an apartment. And my buddy was crazy, and he lived in the same apartment complex. And he would always show up at night, on a Saturday night, like 3 a.m. Because I didn't go out a lot in college because I was in grad school. It was tough. So he would always go out, and he would show up, pull up right outside the window of my apartment. I was on the second floor, and he'd blare that song, Sister Christian. You know what I'm talking about?
No.
You never heard that song?
No.
No?
I probably have.
You probably have. You probably.
Yeah.
Sister Christian? No.
You want to play it sometime?
Can you sing it for us?
I can try. No. We'll play it on our break or something like that. It's a ridiculous old 80s song.
13.
But anyway, okay, so what now? What are we doing here? Your name, just Christian. I just thought Sister Christian. All right.
I got 13.
Yeah, but how? How'd you get there? What are you doing here, Christian?
So what I did is I don't know the technical term for it, but I just turned it into the equation how 80x plus 55 and I made equal
Perfect.
to 1095.
Okay, so the difference between this problem and the previous one is that this one is asking for the cost if you take so many hours, right? The second question is saying, here's the cost, how many hours did you take? It's backwards. So we're setting the cost function, the tuition function, equal to the total cost and solving for the number of hours. And then you just went through this, right? Subtract 55, subtract 55. You get 80x equals, subtract 1040.
Yeah, 140.
And then divide both sides by 80. And you got what?
13.
13 hours. So on your test, on these word problems, I do expect for you to, like if you get 13, that'll be correct. But if you want full credit, you have to tell me hours, all right? Because there's a difference between, $13 or 13 hours. What is this, right? So quantify it for me. I wonder if I even play Sister Christian, if it'll even come through the speakers. What is it? I think it's Sister Christian.
Right there.
Night Ranger. I know when you hear this, you're gonna have heard it before. I don't like the song, but he just used to play this and like wake me up at 3 o'clock in the morning and it pissed me off. I don't hear anything. Yeah, oops. What did I do? Did I just go to?
Volume's low right now.
Yeah, but I think I just missed the song.
Now you have to sing it.
What's that? I guess I'm gonna have to sing it. Hold on. The volume is on the wall here.
The song isn't a superstar. You sing superstar.
Maybe I have. Have y'all heard it?
Yes.
Who has not heard this? Come on, I need to know how old I am. You have not heard this song? Okay. This is not the part he played. You know, at 3 o'clock in the morning, this is not the part he played. Why are we listening to Sister Christian right now? Thanks, Christian. This is the part he would listen. But come on, y'all love this song. See, this is an amazing song. That part? Okay. Thanks, Christian. Appreciate the entertainment there, buddy. All right, moving on. All right, Joe has a part-time job caring for and walking dogs. This is a tougher problem, so I'm going to actually give you a moment to read it. There we go, I can fit the whole thing there. And let me tell you who's up. Timothy's up. Do what?
Could you read it out loud?
Yeah, I can read it. Joe has a part-time job caring for and walking dogs. That's a job nowadays, right?
Mm-hmm.
Okay. He estimates that his annual means what? Yearly insurance, etc., is $420. On average, he spends $4.50 on gasoline per visit. He charges $15 per visit. Note that this is an annual cost function, and it asks what is the one-time or annual charge or fixed cost. Then it asks what is his variable cost, and then it asks you to write the cost function. That is a little more confusing. Would you agree? A little bit? Okay. So who's up? Timothy?
I have one question.
Yes.
Is the insurance is that like a fixed rate? Like, is that what he charges, or like a deposit or something, $420?
So to have this little company he has where he goes and walks dogs, he has to have insurance, because if the dog gets loose and hit by a car, he's probably going to get sued, right? So he has to have insurance. And there's an annual charge of $420 for that. So that is a fixed cost. I think you've already answered the first part for us, yes? Mm-hmm. No matter what happens, if he's going to run his business, even if he walks no dogs, if he's going to have the business, he has to pay $420, right? Agreed? Per year? Okay. Who's up, Timothy? Do you want to tell us about the variable cost? This is the one that's a little tricky. What costs change?
Oh, it's the 450 and the 15, but the 15 is what he's gaining.
Uh-huh.
450 is what he's spending. So by the variable cost, does it mean how much he's spending for each one, or gaining?
Yeah, this is a little bit confusing because it's asking us for the cost function, right?
Okay.